Hi, welcome to another exciting video of Stream Developers. This tutorial will help you create and integrate live event streaming into your Android and iOS apps using React Native, allowing people to chat, interact, and watch live events together. We will use the Stream's React Native Video SDK, allowing developers to build live streaming, audio and video calling, and audio room experiences in no time. If you're new to Stream Video APIs and SDKs, visit our website and go to Developer, Video and Audio. We have the available video SDKs such as React, iOS, Android, React Native, Flutter, JavaScript, and Unity. To follow along with this tutorial, you can find the final project from this GitHub repository. Under the folder React Native, you can get the final project of this tutorial in this folder. Before we start, let's look at what we will build in this tutorial. The live streaming app will have only one screen. So we have a button to start and stop the live stream. At the middle of the screen, we render the host video, and on the top, we show the number of participants watching the live stream. To follow along with this tutorial, you will need Xcode, VS Code, Android Studio, and Terminal. We will use VS Code for the actual development, Xcode and Android Studio for iOS and Android specific settings. Let's begin by creating a new React Native project in the command line. I'll show you how to install the Video SDK. Then we will prepare our environment to run the app on Android and iOS. We will dive into broadcasting live streams from Android and iOS. Finally, we will look at how to render a live video from a host. So let's begin. Let's open Terminal and create a new React Native project. To create our new React Native project, I will add this command. So we want to use the latest React Native template to create a new project called Livestream. Let's press enter. So the command we just entered is going to generate our new React Native project. So here it is asking whether we want to install CocoaPods or not. Installing CocoaPods is necessary for running the app on iOS. So I will press Y to proceed. Over here, you can see our installation is successful, so you make sure you have all the green check marks. Let's move on to the next, installing the React Native Video SDK of Stream Video. To install the Video SDK, we will use the terminal in VS Code, so let's launch it and begin. With VS Code open, I'll go to the location where I saved the project, drag our folder, and drop it on the empty window. That opens the app in VS Code. To get started, let's go to the toolbar and click Terminal, New Terminal. So our terminal is set to the root folder. To install the SDK, I will add this command. So this command is going to add the core Stream Video SDK for React Native to the project. It will also bring all the SDK's UI components, allowing developers to build web experiences. As you see here, the SDK also depends on WebRTC, which helps to establish the call. So let's press enter to install it. We have now installed the React Native Video SDK successfully. It also has some other peer dependencies, such as React Native In-Call Manager. React Native In-Call Manager provides information about call-related actions such as muting, outgoing, and incoming calls. The Video SDK is also dependent on React Native SVG to provide SVG support. It depends on NetInfo to provide information about the call connection status. And finally, Notify to provide push notifications. Let's install each of these dependencies, starting with React Native In-Call Manager. So I will add this command to install In-Call Manager. You can see here that was successful. Then we move on to SVG and NetInfo. Finally, we have Notify. We have now installed the Video SDK and its dependencies successfully. Let's move on to the next. By setting the app for Android and iOS, we'll begin with iOS first. The main settings for running the app on iOS is configuring the app for users' microphone and camera usage. To do that, we first go to the iOS folder of the VS Code project. Then we click Livestream. In the Livestream folder, we look for the file appdelegate.mm, which is an Objective-C file. So in this file, we will add this import that will bring the Stream React Native SDK. Next, we look for this launch options closure and add the setup method. So this is the setup method of the video SDK. To set permissions for microphone usage, we go to info.plist. Below the product name, let's add the following keys and values. So when users launch the app for the first time, they will get this prompt. The product name, which is Livestream, would like to use your camera. And also, Livestream would like to use your microphone. So this is how to set permissions for camera and microphone usage for iOS. Let's move on to the Android folder. Over here, we will import the SDK in the main application Kotlin file. So let's add our import. That is going to bring the Stream Video SDK to the Android project. Next, below the onCreate method, let's add our setup method. In the previous step, we set permissions for microphone and camera usage on iOS. We have to do the same thing for Android as well. So we do that in Android manifest.xml. So in the manifest tag above application, let's add the following. So for the Android version, we set permissions for camera, microphone, and network access. Next, in the Android version, we should specify the version of Java we want to use. We can do this in the build.gradle file. Note, we have two Gradle files. You can see we have one here, which is under the folder Android. But make sure you select the one under the app folder. So we have to add compile options in the Android section. Let's add it below build types. The Java version changes a lot, so it is recommended to check the official React Native CLI setup. The last Android setting we need to specify is to disable the use of newer language features. We do this in Gradle.properties. Let's add this code snippet. We turn off the use of newer language features by setting the sugaring to false. Turning off this feature helps to prevent the incompatibilities. This is all we need to do to prepare our live streaming app to run on iOS and Android. Let's move on to the next to broadcast a live stream from an iOS or Android device. To publish our live stream to Android or iOS device, we will use the app's TypeScript file for simplicity. So let's open app.tsx, select its content and replace it with this sample code. So let's look at a summary of the code. So here we import the Stream Video React Native SDK. To access and work with the video SDK, we need a user. So here we create a user object with user ID, name, and image. Then we create a video client using API key, the user, and token. When you create a Stream account, you will get an API key. You can sign up for free if you do not have a Stream account. The user you see here should be generated from your server side in a production environment. For testing, you can use your API key and our token generator service to create random users for your app. So when we go to the top of the code, you can see here we have defined the API key, token, user ID, and call ID. To make this tutorial simple, we provided all these user credentials for you. You can obtain the credentials from the live streaming tutorial in our documentation. You can find them at step 3. And the user credentials will be similar to this image. After creating the video client with API key, user, and token, we need to create and join the call. To create a call with the video client, we specify the type as live stream and provide a unique call ID. The live stream call type comes with default settings that are usually suitable for live streams. So you can create your own type and set permissions in your Stream dashboard. Finally, using the myCall.join method, we'll create the call object on Stream servers and initiate real-time transport for audio and video. So when we run the app, we display the connection about the video client. So when the video client connection is successful, we show an image and this text, how to render a live video at the center of the screen. So before we run the app, we need to fill all these user credentials. As I said before, you can get these credentials from the live streaming tutorial in our documentation. So I will copy each one of them and paste here. I will add a link to the live streaming tutorial in the description of this video. So let's run the app to see what we have. To do that, we need to start the Metro server with yarn start. You can see here the Metro server has started. So to run the app on iOS, we can press I. To run it on Android, we can press A. Let's go back to the project again. As you can see here, it found my iPhone and it is building the app. Before we can run the app on iOS, we need to set the theme and bundle ID. To set the theme and the bundle ID, I will go to the location where I saved the app. Over here, I have opened the live stream folder. So what we need to do is to go to the iOS folder and select the live stream file with the extension XC Workspace. You can see we have the Xcode file as well, but we should open the file that has extension XC Workspace in Xcode. So I will control click it and choose Open with Xcode. So in Xcode, I will select the root folder and head to Sign in and Capabilities. So here we first need to set the theme. I will change it to my name and set the bundle identifier as well. We need to do the configuration for both the main target and the test target as well. So let's change the theme to my name and also set the bundle identifier. Once we do this configuration, we can now go ahead and run the app on an iOS device. So here, let's change the simulator and choose Amos iPhone. We can now click the Run button to run it on my iPhone. You can now see we display an image and this text at the center of the screen to do how to render a live video. This is how to broadcast the live stream using an iOS device. Now that the connection to the video client is successful, let's look at how to render the host video and watch it. The underlying technology uses a selective forwarding unit, SFU, to replicate your live streams over different servers worldwide. Using the SFU technology helps to scale the live stream to unlimited users in real time. To do the local live video rendering implementation, we will select the content of app.tsx and replace it with the following code. Here we import the SDK's video renderer, which helps to render the host video. We have the same credentials we used for the connection, the user object, and the video client. We also imported the following hooks. We initialize them here to provide information about the call state. So use participant count displays the total number of people watching the live stream. Use local participant displays the streamer's video, that is the host video. And use live stream call live shows whether the live stream is in the backstage, that is the pre-join screen, or not. You can check our documentation to learn more about all these call and participant states. So when we run the app, we use the SDK's video renderer to render the host video and a button to start the live stream and also to stop it. This is all we need to do to render the live video of the host. To run the app on Android, we need to install the Android 13 Tiramisu SDK. To install the SDK, you launch Android Studio and click the menu button on the top right. Then you select SDK Manager. On the left sidebar, we select the Android 13 Tiramisu SDK and make sure we have all these highlighted options selected and follow the instruction to install the SDK. Once the installation of the Android 13 Tiramisu SDK is done, we can now come back to Android Studio and run the app on a physical device. So over here you can see I have a physical device attached. That is my Motorola E32. So let's go back to the VS Code project. To speed up the running process on iOS and Android, I have already started the Metro server with yarn start. So over here you can see we have instructions to run the app on iOS. So I have already pressed I to run the app on iOS. And also I have already pressed A to run it on Android. So if I minimize VS Code, The preview on the left is the iOS version and the one on the right is the Android version. So we have a button to start the live stream and to stop it. And also on the top, we display the number of participants watching the live stream. You can see from the top of the screen we have 2 participants, one from iOS and one from Android. To join multiple people to watch the live stream, we can use the companion web app of Stream Video. So let's launch that. So here we can join the live stream as host or join as viewers. Let's click host. To join a stream as host, we need to enter the live stream ID and click enter. Here we come to the backstage where a host and a co-host can make preparations before the stream goes live. Let's go back and join as viewers. Let's click for viewers. What we need to do is to enter the call ID. That is the ID to watch the live stream. We need to use the same call ID in the VS Code project. So earlier in this video, we defined these user credentials. And you can see here we have the call ID. So let's copy that and go back to the browser. So we enter the call ID here. To join the live stream, we have 2 options using WebRTC and HLS, which is HTTP live streaming. Using the WebRTC version, we get a very low latency live streaming. The latency for the WebRTC version is much lower than HLS. However, if you want a better buffering, you need to go with the HLS version. In this tutorial, we implemented only the WebRTC version, so we need to select that. Previously, we had 2 participants in the live stream, one from iOS and one from Android. Over here on the top left, you can see we now have 3 participants. So one from iOS, one from Android, and the last one from the web. Let's go back to the iOS and Android versions. You can see here they also display 3 participants in the live stream. So this is all I have for you in this video. I showed you how to create a live streaming app for iOS and Android using the React Native SDK of Stream. We scratched only the surface. To learn more, you can check the advanced features such as adding notifications, managing hosts and co-hosts, integrating screen recording, and adding custom events such as reactions. Thanks for watching this video.